Good evening, everyone. Today's session is on stemming in natural language processing. What are the different methods? What are the types of stemmings? What are the applications of stemming? Because whenever we are using the NLP, we might be come across like some of the definitions. What is tokenization? What is lemmatization? So here, this session is totally we are focusing on stemming part, how different functions, what are the types of functions have, how it basically removes the affix part from a word, and whether the word is meaningful or it is meaningless. Let us understand and begin with the session, right? So, what is stemming? Stemming in this step, basically, the remaining words are reduced to their root words. So, like if you have, I will be showing the examples also. You are basically removing the affix part, affixes from the uh, your word. Right. In other words, you may say stemming is the process in which the affixes of words are removed and the words are converted to their base form. So, like suppose base form means your raw form of a word. Like suppose I have taken some examples. Uh, it might be possible like you have some words like healed, healing, healer, studies, or studying. So if you are removing the affixes part, if you are removing that part, so you may be having heal, heal, then again heal, then study, which is not any word, right? And this is a word. So what do you understand from this process? It removes the affixes, right? But whether the remove word, whether the affix when after removing the affix, whether the remained word is meaningful or not, it doesn't matter in this case, right? So stemming, only the part of stemming, only the like process of stemming to remove the affixes part. It might be possible that the word becomes meaningless, right? It does not provides any meaning after removing the affix, so it doesn't matter in stemming words. So this is the disadvantage of that, and that would be covered in lemmatization when we are removing the affixes, and we have to have maintained like the word should have some meaning after removing the affixes, right? So this is the difference between stemming and a lemmatization. So let us understand the other words. What are the different types of stemming we have? What are the different stammers we have? Right. So here we see you can see the example healed, healing, healer. All were reduced to heal, and studies were reduced to study, which is not a meaningful word. This is have you ever encountered this word study? No, you have encountered with this word, right? So here if we remove the affixes part, we are the word that is fetched after removing the uh, affix is study, which is not a meaningful word, right? So this is the main disadvantage, I would say. But we need to just understand also why there is a need of removing the affixes, because we need to generate the TF-IDs, and in the process of TF-IDs we need to have the stemming and lemmatization, both the processes, right? Stemming does not take into account if the stem word is meaningful or not. So it is not the responsibility, it is just removing the affix. So this is just an algorithm which removes the affixes part. It just removes the affixes, hence it is faster, because it does not check it out whether the remain word would be serving a meaning after removing the affix. So it does not matter, because it is faster, it is just removing the affixes part and gives you the remaining word, right? Now why it is important? So before moving into important part, the important term is corpus. What is corpus? The term used for the whole textual data. Like you have a complete document, the whole text you would be taken as all the documents all together, and all the textual text, data text that is containing in all the documents would be taken as a corpus, right? Now, as we have seen in an English language, several variants in a single term. The presence of these variances in the text corpus results in the data redundancy. So you might be facing like the same word is repeated again and again. There would be a redundancy in data, right? So such models may be ineffective. So you have to make a system that is robust, right? To build a model, a robust model, it is essential to normalize the text by removing the repetitions and transforming the words through their base form through stemming. So this is the use, this is the importance, this is the need of stemming, why we require to remove the redundancy in data, why we have a like repetition kind of thing. We just need the base form of any word. Now, what are the applications of stemming? It might be used in information retrieval. The main process is like when you want to retrieve an information, you may be text mining, you may be searching for any text, you may be searching any results on the web, you may be indexing or you may be tagging the systems, and you may be analyzing the document. Stemming is employed. So there are a number of applications where stemming is required. For instance, a Google search for prediction and predicted returns a comparable result. So this is how it is used in our real world scenarios, right? So these are some of the applications where we use stemming. Now let us understand the different types of stemmings we have and what are the examples that are associated with it, right? So there are different kinds of there are several kinds of uh, stemmers, and stemmers are nothing more than a stemming algorithm itself. So I have already discussed this thing. Whenever we are talking the domain that is natural language processing, we might be using in Python, we might be using the package in Python that is NLTK, Natural Language Toolkit. We might be using this library for having some like different functions related to language processing, right? Now, first type of stemmer is Potter stemmer. Now, what is Potter stemmer? Basically, it was invented by Martin Potter, right? In 1980, 5 steps of word reduction are used in this method, each with its own set of mapping rules. Potter stemmer is the original stemmer and is renowned for its easy to use, and rapidity. It fastly basically removes the affixes pad. A resultant stemmer is a shorter word with the same root meaning, right? So it is the advantage. So Potter stemmer is a module. I told you it is a function. You may be talking about a function. You can say it as a module also, and that is in a NLTK. I told you the library that is used for natural language processing is NLTK, that implements the Potter stemming technique. Let's see one example. So here we stem a list of words. You might be come across a list that has the items. You might be having a list of words: connects, connecting, connections, connected, again connection. Connections are different thing, connection is different thing, then connectings, then connect, right? So using this function word, that is I would say the list that is containing the different forms of connection, or you may say the word is connect. So yes, if you use the Potter stemmer, it is going to give you the base word, it is not going to provide you the word that is meaningless. So yes, we have in all the situations we have received the word that is meaningful. So Potter stemmer is the basic method for extracting the base form. The next is snowball stemmer. What a snowball stemmer function does? It is also created by Martin Potter. The method utilized in this instance is more precise and is referred to as English stemmer or Potter to stemmer. Yeah. it is somewhat faster and more logical than the original Potter stemmer. Snowball module. Again, it is a function. Again, it is a module that implements the snowball stemming technique. Let us examine. Let us take one example of it. So again, you have taken a list of words that is basically talking about generosity or generation or generate, generous or generously. So there are number of like you might be having adverb, you might be having an number of words like generous again, and maybe you might be taking any adjective, adverb, anything you may taking, and then let us see snowball stemmer is going to perform it or not. So in that case, we will be importing this function, that is this module snowball stemmer, and then I'm going to put a list of items in the words, and then we check out the using the for loop, and we call out the function one by one. It is going to check for each and every. Why we are using this for loop? Because we have taken a list of item, we need to check each and every item in the list. So that's why we are talking about the word that are in words. Okay, so here we have the first word, that is generous, and that is converted into generous itself. If we are talking about generate, so it has basically deleted base form is generate without e, right? Generously, obviously lee is removed from that part, and asian means shun part is removed from the generate. So it might be possible, like you have seen, it is the some words are not have some meaning. So it basically uh, implements the function, implements the definition part also, that your remained word might be possible, would be a meaningless word. Let us see the next method, that is Lancaster stemmer. Now in Lancaster stemmer module, it is a straightforward, although it often produces results with excessive stemming. Overstemming renders stems non-linguistic or meaningless. So again, I am telling you, if we are using stemming techniques, we might be facing the same problem. The base form might be your meaningless words, right? But it is faster technique, so we are using it in our information retrieval processes. Like if we are searching anything and we are just want to search it very fast, so we might be using such kind of modules, right? Again, let us see some of the examples of Lancaster stemmer. So we have taken the words that are list of words that are associated with eating or eat, right? Eating, eats, eaten, right? Then puts and putting, right? So there are a number of words in a list, and we are applying the Lancaster stemmer for uh, performing the stemming function. So it might be possible, like in this Lancaster stemmer, most of the words, like when you get the base form, and the base form would be in a correct output, right? It is in a meaningful, yeah, it the base form, it's itself representing all the words that are coming in an output string would be a meaningful base forms, right? Like you have eat, you have eat, again you have eat, puts is put, putting is again after removing the affixes, and you are getting the base form, and that is again it would be a meaningful word. So these are the some words, like in the previous one, have you noticed this thing in the previous function, that is snowball stemmer, e is removed and the word does not have a complete meaning, right? Here also generation, the shun part is removed, the whether the raw form is having a meaningful word or not, it does not matter. So yes, this is the main disadvantage of this method. Yes, the advantages would be your, like it is faster technique for information retrievals, and it is widely used for searching any information on the any web search engine. So most of the search engines are using the stemmer algorithms, right? They might be using some of the functions like snowball or Lancaster, or you may say Potter. Oh, Potter function, right? This Potter stemmer function. So it might be possible, like you are using such kind of functions and facing the disadvantages and advantages part also. So yes, I would say, like in the first part, like in this part, everybody wants the results in few seconds, right? So for having the results, like which search engine or most of the search engines are using such kind of algorithm, such kind of stemmers to have the to have efficient output, but it is going to provide you the fastest output. But maybe it might be possible they are inefficient. Sorry. So we have studied about Lancaster. In Lancaster, what is the main thing is, it is going to have the words which is sometimes it happens like, if it is having a shun part, or you may say h part, ate, it is not going to give you the correct uh, yeah, base form. So I would say, there are number of methods, there are number of like you might be facing number of you might be using number of functions, but according to the application you are going to use the stemmer module. So let us see the next module, that is regex. Basically for regular expressions, most of the time we are using the regular expression for extracting the text from Google search also, right? So we might be using this method, right? So regex stemmer identifies morphological affixes using regular expression. So this is like what we have. So substring matching the regular expression will be discarded. And this is a function, this is a module in NLTK that implements the regex stemming technique. Let us try and understand with an example. So here we have another example which is using the regex stemmer. So as you have your regular expression in yeah, like in programming we are using regular expressions, or like whenever we are using web scraping, right, and we want to search any website, we might be using this regular expressions, right? Regex library, we used to have a regex library or regex functions for such type of functions. So I have used that web scraping function, I have made one module and I have used regex expression for that purpose, right? So it is like somehow we have, it's good, like we have this expression stemmer also, which is a module for extracting the base forms. So you have mass, you have was, be, computer, and advisable, right? Again you have used the word for loop for extracting the this thing. Now let us see, you have used the regex expression dot stemmer, right? And then you are taking the word as as an argument. Then mass is not a, mas is a relevant word, is a meaningful word, no, right? Was is obviously you cannot change that part, the was would remain was, even if it is like you are removing anything. B would remain b, right? You may be like it is be, but it is giving you the correct part because there is no affix in that. Computer would remain compute also, but it is giving the full part. Now again the advisable is coming as a advice, and which is not a meaningful word. So it might be possible using stemmer functions, using different stemmer functions. Regular expression is I would say the most effective function, but yes, because stemming function, the technique of stemming we have learned, we have come across also, we have seen in the corpus, like it might be giving you a meaningless words, but within few seconds, but it is too fast to calculate all such things. Like after this, like I would be like having the lemmatization, or I would be having uh, sentence segmentation after this, right? So that I can extract the sentences into tokens, and then I would be performing, I would be generating the TF-IDs for that, right? So in that case, we will be having such kind of words, right? So like using these functions, it is not they are giving the meaningless words, so they are not used. No, they are widely used. We are using on Google search also. Every time you are not typing anything, you are just typing two words or three words, and the word is automatically predicted, right? It gives you the number of fx's, it joins also, right? You need not have to type everything on the Google, because the only thing is, because there are number of prediction text also, that is again one of the application of NLP only. But here we have the stemming part, I would say. It is very very useful in the information retrieval part, right? So most of the people are using this. It is like when we are generating the different programs, we are generating the different web scraping tools, right? In web scraping tools, it is widely used, these types of stemmers. So let us take some more examples. I would say in this particular slide, like we have the healed or healing. I would say like car, or you may say care, right? Or caring. So if I am going to use here, let me tell you the difference of both the things. If I'm going to use a stemmer for caring, right? The base form which is converted using a stemmer function would be a car. So it is logical. Caring, something else I am talking about. Now, if removing the affixes part, I'm getting the base form which is not logical, and even it is not related to caring part. So this is what the disadvantage is. Yes, it is very faster just removing the affixes and giving you the output, right? Is it like whenever you have a very very high confidential type of data or security is there, so we might not be having such kind of functions. Rather than we can use lemmatization for this, because in caring, like lemmatization is going to have your care part. It is going to convert it as a base form, because it gives, it also affixes, it also removes the affixes part, but it is going to give you the base form only, but having a meaningful word after removing the affixes, right? So this is the difference between when we have stemmers functions and when we have uh, lemmatization, right? So my in my next session I would be telling you about the different methods, the process of lemmatization. It is again going to happen like this only, right? Stemmer is more faster because it does not check out whether the word makes the whether the base form makes sense or not at the end, right? Whereas in lemmatization it is checked, right? Whether the base form, the word that is in the base form is very much meaningful or not, right? So it reduced according to that. Here you may see like your care also, if I reduce it to the base form, it would be coming as a car only, and caring, so obviously it is car, right? And that is not matching using a stammer, because it only gives you a base form, right? So when we talk about the stemming does not take into account if the stem word is meaningful or not. It does not talks about, it does not take that particular responsibility that your complete word or your raw word or your, you may say your base word make sense or not, right? But you may say it is faster technique because it is not checking the grammatical, or you may say the rules, right? Whereas in lemmatization you may have to check each and everything, right? So again, we have already discussed the number of types of stemmers and how we used, how they produce the different logics. The most widely used, I would say, the regex, because it gives you the most closest word, but again it is going to give you the errors part also. So in lemmatization, in my next session, I would be telling you about the lemmatization. In lemmatization, we are the same process. We are removing the affixes in lemmatization also, but the base form of the word would be a meaningful word. This is what the difference between stemming and lemmatization. So I would be telling the differences also, not only single difference. You might be seeing like, you are removing, the process would remain same, but there you have certain, it takes into account whether your base form would be a meaningful word or not. So yes, it would be a meaningful word in case of lemmatization, and it is meaningless in case of stemming process, right? So hope you have understood all the topics which we have covered today. So we have covered the number of functions, the number of types of stemmers, and the applications part of stemming, because when we have the stemming part, most of the students get confused. Both are same, lemmatization and stemmers I have come across, ma'am, both are same. Stemming is also giving the removing the fixes, and stemming is also removing the fixes. But the basic part, you should understand this thing. If I am talking about, if I am talking about like this word, I would say studying your studies. So through through stemming process, it would be giving you the word. Through stemming, it would be giving you till this part. I study till this part. But using lemmatization, it is going to provide you a complete word. The base form of studies is study, right? So this is the main difference you need to understand. In stemming, it is generally, it is just, it does not take into account whether your base form would be a meaningful or not. Whereas in lemmatization, we check out, it takes the account, it takes the responsibility. By this method, we are going to remove the affixes, we are getting the base form, and it is what, it is a meaningful word, right? I hope you have understood the types of this stemmers, the different methods, what are the different applications of stemming, and the main thing, which library we have used for using the different types of stemmers, that is NLTK, that is NLTK. Now in previous packages also I have not explained this part. Let me give you a brief part of this. NLTK is a library. From there we have taken the stem part, stem object only, stem class only, which consists the number of functions like a snowball stemmer, a potter stemmer, or Lancaster stemmer, or regex stemmer, right? So in this library, like this is the basic library for using the stemmer functions, and the same library, not the stemmer, we will be using some other library for lemmatization. So this is you need to import this package, otherwise your different types of stemmers won't be working, right? So I hope you have understood the different types of stemmers. What do you mean by stemming? The concept, I am it is like very much clear to you, and the different stemmers. and what is the advantage of stemming. And in the next class, I will be telling you about lemmatization, and I will compare both of them, like why stemming is used and why lemmatization is used. Right? Hope you like the session. Thank you.